Now, could you have said, and I'll put a note, and this is for some of you, I know you already know this. You will say, yeah, I remember you multiply 4 to both sides. Fine. And then you'll tell me, can I just cancel my 4s now? What's the answer? Yes, if you like. And then what's left is your x, and that still equals a negative 12. Did you guys notice, isn't that the same answer? Is that the same answer? Yes. Yeah. But like I said, I've gone through algebra classes where I've noticed that some students, this is like an Achilles heel for them. They're not sure what's happening with that 4 there. That's fine. Is it clearer then to write this as a 4 as a fraction and use your multiplication of fractions, 4x over 4? Is that clearer for you? Then you could do this. Okay, you guys okay with this? See what I'm saying? Okay, let's give you more examples. X over negative 2 is 6. Solving for x. So what's happening with x again? You're going to divide by what? Negative. By negative 2. Negative 2 is being divided into the value x. Is that right? So how do you undo division again? Multiplication. But you multiply by what? The same number. Negative 2 times that fraction on the left. Negative 2 times the number on the right. I put the parentheses here just to emphasize that the number is negative. Okay? Okay, you guys okay with this? Do you guys agree I multiplied both sides by negative 2? Yes. Okay, now I'll go through every gory detail. This is really negative 2 over 1. I multiply across, okay. Negative 2x over negative 2, okay, is 6 times negative 2? It's negative 12. Now, what happens again here is called the cancellation property. Your negative 2's go away. And you're left with x is negative 12. Ah, just by coincidence, same answer as the first problem.
So do you think it's better to learn it this way as opposed to just canceling it out?
I think it depends on the person. If you're a person that knows really that that's what's happening, you know it well, then okay, you could just cancel there. But if you're someone who's like, I'm not so sure, I would suggest you go through this detail until you convince yourself that you can simply cancel. And that's kind of what you need to do sometimes. You know, you go through the long way until you feel more comfortable. When you feel comfortable, you go, okay, I can cancel the negative 2's. Okay, anybody have any questions on this? You sure? You're positive? You know, these are what I describe in my mind as sort of the basics for solving these linear equations. And these are the basics that you have to master when you solve linear equations. Okay, you guys okay with this? All right, how about this question now? X over negative 7 is positive 2. So what do you multiply to both sides?
7.
Positive 7?
Negative 7.
You multiply by the number that is doing the dividing. What number is doing this division? It's a negative 7. So you're going to multiply both sides by negative 7. So I'll put multiplication, a parentheses just to emphasize that this number is negative. Okay, you guys okay with that? Yeah. Then this is going to give you negative 7x over negative 7. And that's going to be, what's 2 times negative 7? Negative 14. what happens? What property do you use? Cancellation. Okay, you guys see how that cancellation just shows up? So then x is going to be negative what? 14. Let's double check. Let's note, what does all of this madness mean again anyway? That means that when I take the number that we solved here, the value here, negative 14, divided by a negative 7, isn't that a positive 2? So you get what's called a what? A true statement here. This also means that the value of 14 is a solution. Okay, so you found a solution here to this equation. This is called a solution. The value that gives you a true statement is known as a what? It's a solution. Comes from the word solve. Okay? No? Is that easy? You sure? Well, can I erase this? You guys have this in your notes? Okay. Well, I'm going to give you what's known in my mind. I think of this type of question as a typical question. You know, typical. I kind of feel really that, and I know I told the 112 students when I taught this subject to 112, pre-algebra, I think I told them, you guys have to solve this kind of thing in your sleep. You know, meaning it's kind of what you typically see. And it's something like that can look like this. 2x minus 3 maybe is, I don't know, negative 15. And so what's happening now to the variable x, you're solving for x. What's happening now is two things. 2 is being multiplied to x, and you also have the subtraction of 3 on the left side. You guys okay with that? So you're solving for x. It may not be so easy to do. Some of the prior examples, you might have been able to guess what the answer is. Now it gets a little bit harder to guess. Okay? So you're going to have to use those tools. Yeah, what do you do first? Does anybody know? The real answer is it doesn't matter. But one approach is a lot better than the other, meaning there's less tedious work. Yes. What do you want to do first then with this? Instead of isolating x right away, because you could get it. I mean, you can't isolate x in one step. You got two operations. 2 is multiplied to x, and you're subtracting 3. So you have to undo both of them. And you have to undo both of them one at a time. So you can undo by dividing both sides by 2 first. Don't recommend you do that. Or you can undo by translating this 3 first. Okay? So in the typical setting, you want to translate this first, okay? Now let's see, what does that do for you? You still have 2x. That's going to be negative 15. I didn't move the 2x term. You guys agree with that? I didn't move negative 15. They're still on their sides. I moved this 3. It's now on the other side, and it's now what? Positive 3. I changed the sign. This is translation. So 2x equals, what's negative 15 plus 3? Negative what? 12. So now notice, doesn't this look like the problems that we did over here?